So, I want to talk about how to get into graduate school, and I am speaking from experience. I've my experiences as a professor at Colorado State University, but also talking to other faculty at other universities, as well as watching my undergraduate students go on to graduate school. So, that's the some of the perspectives that you'll learn about. So first of all, I want to say that just for in terms of terminology, a lot is said these days about data science, and so for what I'm talking about in general, I'm going to use the word statistics because that's kind of where I grew up. But I will later on talk about the differences between statistics, biostatistics, and data science, and how that applies to graduate school. So first of all, the world needs qualified statistician, and and I think it's basically what I'm trying to say is I think it's a great career to go into. Statistician was ranked the best job in 2017 by CareerCast, and I should say that I didn't even look at the latest rankings, but it's a good job, and there's lots of jobs. So, what can you do if you go to graduate school? So, this is kind of looking at the end of things. So, here's some examples of what some of my students have done after graduating. I have several students who work at pharmaceutical companies helping scientists discover new medicines and manage ones that have been discovered. I have several students who are teaching and doing research as professors at universities. One of my students is the head of data analytics for a major league baseball team. Another student integrates energy sources on massive power grids. And then another student does model sea lion populations. And so my goal there was just to show you about the diversity of things and that you can do, but also to show you that if you go and get a degree in statistics, you can go to lots of different places and do lots of different things. So next I'm going to go through these various factors about how to get to graduate school. And I was for many years the undergraduate advisor at my university. And so I developed this talk over time by answering a lot of questions from my students. So first of all, deciding whether to apply. So, in general, with a master's or a PhD in statistics, you get a higher paying job, more responsibility, a more interesting job, and more independence in your job. So, all those things sound great. And so, again, I'm trying to encourage people to apply to graduate school. However, I want to make one note that I don't think that graduate school is for everyone. So, in particular, you need excellent grades, a desire to work hard, and focus and intensity. And some students are missing on those things. And so, for example, if you don't have excellent grades, you might still be able to go to grad school as long as you have the last two things, a desire to work hard and focus and intensity. But if you're missing two out of the three of these, I'd say don't go to graduate school just yet. So here's one way to kind of think about it, and you might use this as a litmus test. So here's a quote from one of my former students. She said, "Graduate school is so cool. In undergraduate classes, professors tell you how to do things, but in graduate school, professors tell you why they do things." So if the why is sounds interesting to you, then graduate school might be a great fit. If you're fine with kind of what some undergraduate classes are what I call cookbook statistics classes, where they just teach you some rules and you apply them, then maybe if you're fine with that and don't have further questions, then maybe graduate school may not be for you. But overall, I'm trying to encourage people to go to grad school. I just want to make sure it's a good fit. Okay, so other things you can do to decide whether to apply. You can do a summer program to explore graduate programs. There's things called REUs, Research Experiences for Undergraduates, and there's other programs. So talk to your undergraduate advisor about those things. You can do, as one of these REUs, you could do research with a professor in statistics or mathematics, or there's other types of programs for undergraduates, or you could get an internship. I would definitely talk to your favorite statistics professor. And I've flagged students and said, hey, you should consider grad school, or they've come to me and said, should I go to grad school? And I'll give them an honest answer. So talk to your favorite statistics professor about why they went to grad school and whether or not you should. Okay, where should you apply? So there's different types of programs. There's statistics programs, biostatistics, and data science. You just heard the previous speaker, Jennifer Thompson. She got a degree in biostatistics. I have a degree in statistics. We both fit under the umbrella of data science, even though our degrees weren't formally called data science. And then you have to make the choice of the type of program, and I'll talk a little bit more about that, and then whether or not to get a master's or PhD. And the choice for these depends on your career goals. I also want to say, don't worry too much about this. If you choose one of these and it turns out to be not a good fit, you can transfer or you can learn on the job. But you do have to decide because you can't apply to everywhere. So here are different types of programs. So if you apply to a Department of Statistics, what do the students do when they graduate? Well, in general, they're hired by everyone, businesses, universities, government, etc. They can focus, these graduate programs can have a more theoretical focus or a more applied focus. More commonly these days, it's both in a PhD level statistics program, but in a place that has master's degree programs in statistics, they tend to have an applied focus. If you go into a biostatistics program, in general, making gross generalization, graduates tend to be hired by drug companies, so pharmaceutical companies is the proper name, and go into public health fields. And I think Jennifer Thompson, the last speaker, was a great example of what a biostatistician can do. She was working for a university in a research type position, and then now has moved on to a company relating to health, and those are more and more common these days. In general, in terms of graduate school programs, the biostatistics programs are usually more applied focused than statistics programs. So they're analyzing data is what I mean by applied versus doing the theory. Now, in all graduate programs, you do some of both, but just in terms of the balance of focus. And then finally, data science. In general, data scientists are hired by everyone, but certainly businesses are more interested in them. Almost all data science programs that I know have an applied focus. The one thing I will say is that everybody and the brother is trying to do data science. And so you should use care when selecting a program. And I really wouldn't, I think you're fine if you choose any of these statistics, biostatistics, or data science programs. But so it's fine if you want to go into data science, choose a statistics program, for example. But use care when selecting a program because, for example, some business schools have data science programs, and that's more like an MBA program than what I would consider a statistics program. So just that's fine, but just know what you're getting into. You can look at the classes to determine that. Okay, so next you need to decide where to apply. As part of deciding where to apply, you need to decide whether or not you want to get a master's or PhD. My first thing, I guess I should say, is I wouldn't worry too much about this one either. Start by going into a master's program, and then you can decide later whether or not you want to get a PhD. There is one caveat to that, and so let me explain this. So with the master's degree programs, there's many different types of programs. Now, these days, there's more and more programs which are considered to be a professional master's program. And then there's traditional master's in science programs, MS programs. And so both are very good programs. They can, types of programs, they can both lead to great jobs. The one thing to realize is to know which kind you're getting into, because some professional master's programs do not have a way to go into a PhD program. For example, at some universities, if you take a master's program, which is either 1 or 2 years long, and then you decide you want to go into PhD, you'd have to start over essentially. Whereas if you go into the academic master's MS program that leads to a PhD, then after 2 years, you're in the PhD program and you don't start over. So if you know you want to get a PhD, I would not go into a professional master's program. In master's programs, there are some, most of the programs are on campus, but some programs are online. And so that offers a lot of versatility, especially for people who are working or wanting to do other things with their lives while going to graduate school. Then there's PhD programs. So as a student, the difference between a master's and PhD program, in addition to length, is that a student in a PhD program needs to innovate. So that student needs to create new statistical theory and methodology, and that would be true no matter what program that you're interested in. A PhD is required to be a professor, but they're also very useful for industry positions. A lot of industry positions, I was just reading an article where they said, we just want you to have a PhD in any field, really, but particular in statistics, because that means that you have a particular set of skills that the businesses want. So another question to consider where to apply is whether to apply to top ranked universities. I always have students, because they all have good grades, the ones who want to go to grad school anyway, say they want to get into a #1 university. And that's fine, but very few people can only get into the #1 university. So I would be real careful to decide whether or not you want to apply to the top universities. So these are the types of questions that you want to ask yourselves. And at the end of this talk, I'll show you a link to all my slides. So if I skip some, you can go back and look at these slides. So how to apply? What classes should you take as an undergraduate? Well, requirements for graduate programs vary. However, here's an example of the types of things that we require at Colorado State University and many other universities. So for our PhD program, we require calculus through what most people call Calc 3, linear algebra, and then for our PhD applicants, a proofs-based course, something like real analysis, but it can be any class where you're doing proofs. And then additional programs, classes that are useful are statistics, computer science, and additional mathematics. I want to emphasize you don't have to be a major in statistics or mathematics. As long as you have these classes, that's fine. So that's one thing that's nice to know for those of you out there who are getting minors in statistics or mathematics. So how to apply? These are the types of things that are required by most universities. The application form, just some online form, that's #1, and then grade point average, your GRE scores, letter recommendation, personal statement, resume, and then international students have an additional test that is sometimes required. So what do universities look at? It does vary by school. However, GPA is generally very important, especially for your mathematics and statistics classes. So if you have mostly A's and B's in your math and stat classes, you're a candidate. But if you have a few C's and D's in math and stat, then at a lot of schools, you're probably not a candidate that they would consider. #3, this GRE score. What's especially important is how you do on the quantitative section of the GRE. Some schools are using GRE score less in terms of it's not as important as it used to be. So I would do your best, of course, on it. But if you didn't do wonderfully on it, there's still schools that might consider you. The letters of recommendation are generally very important. Definitely talk to your advisors about how to get letters of recommendation. You want letters of recommendations from your professors. You don't want it from your job at Taco Bell. You want academic recommendations, and it should be mostly from your math and stats professors. And then your personal statement. I found that students really worry about the personal statement, and you should make a good effort at it, but don't fret about it too much. It won't make or break you. If you have good letters of recommendation, good grade point average, etc., then you've got a good packet. And so you just need a pretty good personal statement. An amazing personal statement is probably not going to make or break you for most people, especially because a lot of students they're just good students, and they don't have much else to say, and so that's okay. So don't feel bad if that's you. So importantly, how to pay for graduate school. For master's only programs, many of the programs require you to pay for graduate school, but most PhD programs, they do not. So if you have good grades as an undergraduate and you get into a PhD program, then the school will pay your tuition and then also pay you for your living expenses and health insurance. So if you didn't know about this, then this is a big heads up, is that you can go to graduate school for free. And some master's programs will also have the same setup. So definitely look into this. There's other options as well, like getting a job and having the company pay for it. And that's a very good option as well, but not all companies will do that. So if you're interested in a PhD, definitely try to get it paid for. And most, like 100% of our students at Colorado State in our PhD program have it paid for, and some of our master's students do as well. So when do you apply? Well, the deadlines vary between November to March, but my most important thing is make sure you apply by the earliest deadline. And so, for example, if they say we started considering applications by November 30th, be sure that you get it by November 30th, if not earlier, because some programs will only look at the people that they have on that date, and anybody that comes in later, they won't look at them because they had so many to get into. And so it depends on where you're applying, but you might be competing for, say, 250 among 250 or more applicants to get one of 10 spots. And so you want to get there by the deadline. And then if you want the school to pay for your tuition, be sure to apply for it. Some students don't check that. And I've actually gone back and said to a student before who was really good, did you mean that you want the school to pay for it? And they said, oh, yeah. So I always want to tell people, make sure you apply for that. So in conclusion, statistics, biostatistics, data science, all these fields will lead to fun, fulfilling, and well-paying jobs. They're extremely sought after, people with these skills. And so, a great way to get these positions is by going to graduate school. So I will end there. If you have further questions, talk to your advisor. That's going to be your best bet. We're going to open to questions in a few minutes, but I just want to emphasize that if you talk to your advisor at your school, they can help you. There's more resources at the American Statistical Association's webpage, and my talk is available at my webpage. So you can write that down, or if you just look at my name in the program and Google me, there is a link to talks, and you will see a longer version of this talk with even more information and all the links I've included there. So that's it.
Thanks, Jennifer. So before I introduce our grad panelists today, I want to give the audience a chance to type into the chat box and present some questions for our grad panelists. So we have Tess Hamzeh, a applied statistics student at the Colorado State University. Then we have Clara Drew, a PhD student in biostatistics from the University of Minnesota School of Public Health. And then we have Bryan Martin, a PhD student in statistics at the University of Washington. Okay, so for PhD programs, when do students start doing research?
I can take that one. So I started doing research right away because, for specifically in biostatistics, since it's not really taught to undergrads, most people get an RA rather than a TA. So they'll do a research assistantship job right away, and then you can kind of start working on someone else's project. Farther into your PhD, you can kind of transfer your own research and find your own projects, but they'll basically have you do research right off the bat as part of your funding and your job.
Okay, so how early should students start their application before the deadline for applying to grad school?
I'm happy to answer all questions, but I'm curious for the grad students to say how long they started.
I should have started earlier than I did. I started like the end of that summer. Well, I started studying for the GRE a little bit sooner than that, but yeah, the sooner you start, the better. Like you should at least get your list done like early in the summer, hopefully, of where you want to apply, and then you'll have an idea of what needs to be done after that. But yeah, definitely started too late, and that's a regret.
And let me clarify one issue that comes up. So Clara's talking about is she was applying, say she was applying now. If she was developing her application now, it would be to start in the fall of 2020.
Yeah, so like, I think that would be you know, as soon as you know you want to go, start looking at schools. So I started like most of my applications were probably due in November and December of 2016, and I probably started that summer and really only started like writing the stuff in September and October, which was not enough time. So before that.
So for a different perspective, I am in a Master's of Applied Statistics program, so it's pretty different. It's 11 straight months, or I mean, you get like a winter break. And so my application was due, I'd say, later than the average PhD program. I think it was March 1st or something like that. And then I also had an option to take a specific entrance exam that tested my knowledge of algebra or of linear algebra and calculus 1, 2, and 3. And I hate the GRE. I think it's real dumb. And so I chose to take that exam instead because I was like, yeah, that's what I want to prove to them that I know how to do for this program. And so I started studying for that exam in probably like November, and I took it at the beginning of January. It was just a 2-hour exam. It is specific to Colorado State University. So at that point, I committed to just applying to Colorado State because I was certain that was where I wanted to go. And then, yeah, I think I had everything in, and it was a very similar packet. I needed, you know, the 3 letters of recommendation, personal statement, all that stuff. I had it in by, I think, the end of January and heard back in a couple of months. And yeah, it's also a program where you can only start in the fall.
So I started my application process probably like 6 months maybe before applications were due. For me, I wanted to go back and forth with professors a lot and get lots of feedback on my on my letters, and I didn't really know the process as an undergrad that well, so I wanted to make sure that I had time to get the mentorship I needed in order to write like good letters and prepare myself adequately, and also to know which programs to apply to, because at least for me, I was actually pretty lost in the beginning of the process in terms of knowing like, should I do statistics or biostatistics? Should I do a master's or a PhD? So yeah, I think this seminar has been super informative, and I'm really glad that this information is being laid out there for lots of people.
Okay, go ahead. Sorry.
Oh, I was just going to. So I see in the chat a question, which is how many programs did we apply to? I applied to, I think, 9 programs personally. For me, I was recommended to do like 2 or 3 reach schools, 2 or 3 schools that I thought I had a solid chance to get into, but there's always randomness, so you never know. And then a couple of schools that I would consider like safer on my list as well.
I was raising my hand non-electronically. Just adding to that, something that I didn't say in my talk. So if you think about 9 schools, it probably costs about $100 to apply to each school. So some students, that's out of reach. And most schools have a way to request on the web page if you want that fee waived. Or actually, now that I think about it, many schools don't make you pay the fee until you get in. So some schools we've gotten around that. But if a graduate fee, if a fee is required, you can always, and the same thing for your GREs, you can ask for waivers for that.
Okay. So what is a good quantitative GRE score? And I'm just going to add on to that. Should students, if they're applying to statistics, data science, biostatistics, should they be scared of getting a low verbal score?
My understanding is that they mostly just look at your math score. I mean, you don't want to get like a terrible score on the other sections, but the best you can, I mean, you want to get as close to, if you're going straight to PhD, like a perfect score as you can. But if I remember correctly, the range is like 170 the highest. I don't remember, but anything in like the 160s would be okay. Like you shouldn't be too worried about. But I don't know.
Yep, that's great advice.
I can speak to my program personally and say that so now we don't require the GRE anymore. at all. But when we did require it, they basically completely ignored the verbal score. So, and for quantitative, they sort of used it as a threshold. So they weren't looking for a perfect score necessarily, but they wanted you to demonstrate just basic quantitative skills. So yeah, 160s at the time was.
All that is great advice. If you do have to take the GREs, one thing I warn undergraduates is when you look at it, if you just started, it's a day before and say you hadn't studied at all because you're blowing things off, and you look at it and you say, oh, I can do this stuff because it's like high school math. And that's something that sometimes messes up students, is that it's so old, it's not calculus based. And so definitely don't just the night before look at it. As Clara mentioned, study some and practice, but I would just focus on practicing the quantitative part.
Okay, so what math or stats professors should we ask to write our letters? Only those who taught us upper level courses? That's a good question.
Do you guys want me to take that one, or?
Sure.
Sure.
So I would do definitely the ones where you did a good job, and then where they know you. So one thing I recommend, and certainly the 3 graduate students who are looking at me right now, I'm sure had great scores, and depending on if they went to big universities, may not know the professors because they were such good students that they didn't actually go in to see the professor. And so one thing that I recommend to students is develop your letter writers. So go in and see faculty who you think might be potential and tell them that you're interested in grad school, and it doesn't have to be your advisor. So it really doesn't matter what the level is of the class, as long as the person knows you. I'd say the knowing you is more important, because if they just write a generic letter, all faculty, we all write lots of letters, and if I don't know the student well, I write kind of a generic one, but if I know the student well, I put in more, and that's a more effective letter. Another thing about letters is students always seem really scared about asking faculty for this. Many students do, and I encourage you not to be scared. It's part of our job, and it's no problem at all. And if a faculty member wasn't going to write you a good letter by professional obligation, they should tell you. I can't say that everyone will, but if I only agree if I think I can write the student a good letter.
Yeah, and one thing I would say about that is that ask your professors as early as you can. You're going to get a bunch of requests. Stress you out more than a professor submitting their letter like the day of the deadline will do. So the earlier you ask, you'll save yourself a lot of pain.
I would also say, so I actually didn't apply to graduate school until 4 years after I finished my undergraduate. And so I was required 3 letters. And so I got one from my current manager at work, but then I still needed 2 academic. So I made sure to reach out to professors that, yeah, I'd gone to their office hours. I had a little bit more of a personal relationship with them, but I included a resume. I included my LinkedIn. So if by some chance they had completely forgotten who I was, they could at least see a picture of me, and just letting them know what I had been up to in the last few years and the impact that their teaching had on me, and what kind of program I was pursuing and why. So don't be afraid to reach out after a few years and refamiliarize yourself. And I agree with Clara, give them plenty of notice, and maybe after a few weeks go by, send a gentle check-in if you still haven't heard, just gentle reminders as you get closer to the deadline if they haven't done it for you yet.
That's great advice.
So the next question is,
Could you repeat that, Marisa? I couldn't hear it.
oh, what is the best part of grad school?
I guess I would, one of the things after having worked for 4 years is I do love the structure of school. Like almost anything your professor asks you is going to be Googleable, and they have office hours, and you get a grade. You're getting constant feedback on how you're doing, and if you end up going out of academia and into the public or private sector, a lot of that changes. You might only have 1 or 2 check-ins with your manager a year, and they're like, oh yeah, you're doing fine. And I'm like, no, I crave more than that. And so I've really enjoyed the structure of going back to grad school and that constant learning of new things.
So for me, this one's pretty easy to answer, actually, and it's the flexibility that you get when you're in a graduate school program. So as a PhD researcher, typically you have quite a bit of say in what you want to research and what direction you want to take your projects in. You know, do you want to do more theoretical work, more methodology work, more applied work? And you also get a lot of flexibility in terms of like setting your own schedule, and along with that, I would say like the mentorship. There's not many other places where you can go and get paid to be mentored by some of the top people in the world at your field. So it's really great in graduate school that you meet very often with your advisor, who is going to be, as someone who advises PhD students, a world-class expert in their field, and that's really great.
Yeah, it's definitely the learning opportunities and like the people you can connect with, especially in my program in biostatistics. You work with a lot of people in sort of other scientific fields. You can learn things that you've never learned before and get connected with research in a really easy way because everyone knows each other. So it's really easy to get connected with mentors and research opportunities, and people they want you to succeed in a grad program. They know who you are and they're looking out for you and trying to connect you with opportunities. So that's definitely the best
part. That's awesome. So the next question is, was the transition to graduate school difficult?
Yes, it was. For me personally, the flexibility I just mentioned is the best part. Is also kind of a double-edged sword because while you do have a lot of flexibility, there's also a lot less structure in terms of what you are required to do every day, and it's quite an independent process, which separated a little bit from my undergraduate work. So for me, the transition was difficult, but it was a process that I learned a lot from and that I gained a lot from personally and academically and professionally. So it was definitely worthwhile.
Can I say one thing as seeing lots of students go through it? I want to be encouraging. A lot of times the first semester is really challenging for students because they're used to being the best in their class, and now they're in a class where everyone was the best in their class. And so you're suddenly not the best in your class. And so for some students, that can be a challenge. It's not an issue with everybody, but in general, I've seen that be an issue. And so the one thing to realize, I just want to encourage everyone, is that everyone is struggling or finding some classes challenging. So even if you're not the best in one class, in another class maybe you are doing better, and so then you get to work together. And so that's the cool part. One part of graduate school, which is so fun, is you're working with other students, and you learn a lot from interacting with your other students. And so there's challenges, but then that's also a good part too.
Yeah, I would say that you're going to learn more than you ever have before, but you're never going to be more dumb.
That's a great quote. I'll put that in next year.
Yeah, I agree. I remember at the end of my undergraduate, I was burnt out. The thought of going to grad school sounded exhausting. So for anyone who's going to go straight through, I salute you. Since I took 4 years and I was working in a cubicle and I felt pretty understimulated and challenged the last couple years of that, I was really excited to get back into a more rigorous program where I was using my brain more. And I would say one of the biggest keys to success, like Jennifer said, is collaborating with your peers and working together. The program here at CSU really emphasizes that. They give us a special lounge that we can all work in together. I've found that the students I work with, our skills complement each other really nicely, and we help to fill in our knowledge gaps and feel a lot more comfortable with the material.
Nice. Has your program given you a clear idea of what you want to do after graduate school?
So I'm pretty solid on what I want to do. I worked as a data analyst for the last 4 years for a large tech company, and I knew that I wanted to pursue data science. And so I started looking into programs for that complemented that nicely. And like my program here has a data science specialization or a statistical science specialization. And so I feel confident that that's what I'd like to do. I'd like to work for another tech company.
It's definitely given me insight into what type of research I'm interested in, but it's still an open question whether that'll be like at a university or at an industry or for the government. So like the employer is a little bit more open-ended, but like the type of work that I find interesting, I feel like I have a much clearer idea of that.
Yeah, I'd agree with Clara. I don't, especially like my program specifically, I think the question of like what you want to do after grad school is much more personal, and I don't think programs tend to coach you in one direction or another necessarily. But I definitely did get more into the research I want to work at, which has guided, I'm in my 5th year now, so has guided like what sort of jobs I'm applying for and what sort of jobs I'm looking for after I graduate.
What advice or info did you wish you'd received before going to graduate school?
Okay, I can start with that one. So one of the things I wanted to mention about stats versus biostats is I think I didn't have a full picture when I was applying of the difference between statistics versus biostatistics. And what I did at the time was like picked, okay, statistics seems better for me, so I'm only going to apply to statistics programs. What I wish I had done instead, even though it turned out fine, but knowing what I know now, what I wish I would have done instead is looked at specific programs. So for example, I'm at the University of Washington, and here the statistics and biostatistics programs are nearly identical in terms of exam requirements and course requirements and everything. And we're in many of the same classes. So many people apply to both, and some get into both, and then they get to choose between them. And this is something I wish I had known at the time, and I might have been a little bit more flexible and not just said, okay, I'm going to cut off all biostatistics programs and only apply to statistics programs. So yeah, that's what I'd say.
Or Tess, do you have any advice that you wish you received before going to graduate school?
I guess maybe if I had thought out more, I would say really think about if you're going later and you're working for an employer that would pay for your degree, if you want to do that and what that plan would look like. Because my employer offered some money to help me go to school, but to me they didn't really incentivize me enough. And so I chose to quit school full time and complete it in 11 months. But you can do this program like is drawn out as 4 years. And if I'd drawn it out that much, my employer would have paid for more of it. So I'd say if you're working, talk to your manager, talk to your HR if there's a department that helps pay for your degree. And I worked for a large company, so it was like everyone in the US, it doesn't matter where you go, this is how much money you get. But if you're at a smaller company that's more flexible, see if you can negotiate with them.
Yeah, I probably would have just started my applications either sooner or taken a year between undergrad and grad school because I think I tried to do them a little bit too quickly, and I just remember being super stressed out. Maybe I could have done a slightly better job on them if I'd taken more time.
The next question is, do graduate students have any free time or is it all work?
I definitely have free time. I know my program's a little bit different. I'd say they said expect to spend 43 to 45 hours a week on work. I'd say that's pretty accurate. But yeah, you just got to stay ahead of the curve. And then I find that even there's been times where I knew I was going to be out of town for a whole weekend. So I worked really hard during the week to make sure I had no homework during the weekend. And so it's more intense than undergrad, but there's certainly still free time for me.
Yeah, I say technically you have a lot of free time, but you always have work that you could be working on. So I don't know if you're ever totally free of it, but you can kind of pick your own schedule, and you don't take as many classes as you took in undergrad. So your schedule is more your own to get all your work done. And if you're on top of things, you can make it more reasonable.
Yeah, I'd agree with that. And I'd say the free time that you get, particularly in the later years of a program, like I definitely had less free time in my first and second year when I was doing both research and coursework. The freedom that you get later depends on how much, or free time that you get depends on how much you allocate for yourself. And for me personally, I think early in my third year, I was at risk of almost burning myself out a little bit because I was just working all the time and not giving myself any free time. And after I finished the first project, I kind of prioritized for myself, giving myself some free time. And I think I actually became more productive as a result of that by making sure that like I was working plenty, but also was giving myself somewhat of a work-life balance and enjoying my hobbies and having life outside of school. And I think that's really important for people because you're in a PhD program for a long, long time.
So this will probably be our last question since we're reaching the time limit.
Can I
What
say
class?
one quick thing that I didn't
Yeah.
say? One thing I didn't say, and that I'll bet that at least Clara and Bryan found this, is that a lot of programs after you've been accepted will pay for you to come out and visit them. So don't feel like you have to go visit so much beforehand. I would wait until you get in and then ask them if they have a visit day.
Yeah, that's right.
Okay, so I think we're done with this panel. We just want to thank all of the panelists, Clara, Tess, Bryan, as well as Jennifer. And I want to thank all of the participants that are watching right now. We also want to thank the ASA, Cause, RStudio, Google, and the ASA section on statistical education. Thank you.
Thank you.
Thanks, everyone.
Thanks, everybody.
Bye.